Hello and what's up, everyone? Today we have our Unit 4 Test 2 review. So, let's hop into it. First up, our first question says, what are the coordinates of the center of a circle represented by the equation x plus 4 squared plus y plus 2 squared equals 10? So, the very first thing we want to do here, though, is remember our original equation, right? So the original standard equation for a circle is x minus h squared plus y minus k squared equals r squared, where r is our radius and h and k are the coordinates of a point. R stands for radius. Awesome. So we just need to kind of swap all of this out. And since it's asking for the coordinates of the center, that's what we need to find here, right? So our coordinates are going to be the opposite of what's in here. So we have a plus 4, which means we'll take a minus 4 or a negative 4 for my x. And look, it's right next to that x, and in the same bracket says the x. And then for my y coordinate, it's the opposite of what's here, which is a plus 2, so we get the negative 2. So our coordinates are negative 4, negative 2. And we could also find our radius. It's the square root of whatever number's here, so it's just going to be the square root of 10. 10 is not a perfect square, so we're just going to leave it as the square root of 10. Awesome. And we got our first problem done. Next up, the equation of the circle is x squared plus y squared plus 6y equals 11. What are the coordinates of the center and the length of the radius in the circle? So the problem with this one is it is not in a form that we could use. We need to get it in that form. This is not in our standard form because notice we have a y squared and we have a y here, right? We don't want that. So I'm going to rewrite this: x squared plus y squared plus 6y. I'm going to leave a space here, and you'll see why in a second, equals 11. Now, for this one, we have no other x here. So my x is good as x squared. But my y, we have a y squared, and we have a y, which means we have to factor this somehow. And in order to do that, we need to complete the square, right? And in order to complete the square, we take this number next to my y, so the 6, and we're going to divide it by 2, and then square it. So 6 divided by 2 is going to equal 3. And then we want 3 squared, which will be 9. And what we're going to do is add 9 to both sides of our equation. Remember, you have to add it to both sides. If you don't add it to both sides, your equation is going to be uneven, right? And that equal sign isn't true. We want to keep everything even, keep it equal. So now what we have to do is factor this equation right here, which is easy because remember how we divided that 6 by 2? That's the number it's going to factor into, right? So the way we could write this is x squared plus, and then we're going to do an open parentheses, y, and we could tell what sign to put here by what sign is next to that number that we divide it, right? So what number's next, what sign's next to 6? It's a plus. And then we're going to take it after it's divided by 2, which is 3. Close parentheses and square it. And what this means is if we do y plus 3 times y plus 3, it's going to give us y squared plus 6y plus 9 equals, and then on this side, all we have to do is add those two, which is going to give me 20. And now we could do what we did in our last slide. We could pull out the numbers. Now there's no number next to my x, which means that it's at 0. My x coordinate's at 0. And then my y, there's a number with my y. Remember, we take the opposite. So instead of a plus 3, we'll get a negative 3. And there's my coordinate. And then my radius is going to be the square root of the number that's here. So 20. Well, once again, there is no square root of 20. So we could actually do this as the square root of 20, just like that. But just in case it needs to be in factored form, we can factor this because you could break this up as the square root of 4 times the square root of 5. Which would really equal 2 square root of 5. So just be careful because they might give you the option of the square root of 20, but they might also give you the option of 2 square root of 5. So these are our answers right here. It's 0, -3 as my coordinate, and then the square root of 20 or 2 square root of 5. They equal the same thing. Next up, now we just need to identify what this looks like on a graph. So we have a new equation here. X minus 1 squared plus y plus 3 squared equals 4. My suggestion is let's write the coordinates down, right? So let's do that first so then we could just identify which one is right. So my coordinates for this, remember, x, we take the opposite number. So since it's a -1, we're going to go +1, comma. And then my y, since it's a +3, we're going to go -3. And then my r is the square root of 4, which this one's actually a perfect square. And the square root of 4 is going to be 2. So what do we have to do? Let's check what my center is here, right? It's at 1, 2, -3, +1. Uh-oh, those are the same numbers, but my x is -3 here. That's not what we want. This is a trick answer because the radius here is also 2, right? So this looks like the right answer if you don't know the difference between your x and your y. So we need to be careful there. Remember, x is your left to right. Y is your up and down. So just be careful. So this is not our right answer. Next up, this again is at -3, +1. So we know that's not right. But also, look at the size of this circle. This is more than 2 units. That's also wrong, which leaves us with one more answer. Right here, we could double check it to make sure it's our right one. We go right 1, cool, +1, and then down 1, 2, 3. That gives me the -3 right there. And also, look at that. From the center to the outside is 1, 2. This is our correct answer right here. It is C. Awesome. Next up, now we go to our other topic, which is cross sections. So this one says a right hexagonal prism is shown. A two-dimensional cross section that is perpendicular to the base is taken from the prism. The figure that describes a two-dimensional cross section is a blank. Now, what does this mean? This means we have something that looks like this. We have a plane that cuts through this, right? Oh, look, something like this, right? And then that means what is our cross section here? Well, this is simple. A cross section that is perpendicular to the base of any prism is always going to be this shape here, which is a rectangle. So if we have a cross section that is perpendicular to the base, it's a rectangle. If it's parallel to the base, it's going to be the same shape as the base, right? And that goes for pyramids also. So next up, here we go. What figure can have the same cross section as a cone? Well, if we think of a cone, it has two different cross sections. One that's horizontal and one that's vertical. So one that's parallel to the base and one that's perpendicular to the base. If we're parallel to the base, it's going to be a circle, right? So if we're oh God, I keep parallel. There we go. We get a circle. And if we're perpendicular, we get a rectangle again. So, which of these is going to be the right answer from one of these? A rectangular prism, that could be, actually, but we don't even want that because we want the parallel to the base, right? So our answer here is going to be the sphere. All right, our next problem is says, what figure can be the same cross section as a cone? So if we think of a cone, we have to think about what cross sections it could have. So if we are parallel to the base of a cone, then our cross section is a circle. But if we are perpendicular our cross section for a cone, and the same thing is true with a pyramid, is going to be a triangle. Now, we don't have a pyramid here, right? We have a rectangular prism, where in a rectangular prism, the only cross section available is a rectangle because the base is a rectangle. And then, so both cross sections, parallel and perpendicular, will be rectangles. So that's not our answer. A sphere. There's only one cross section to a sphere, and it's going to be ding, 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 a circle. A circle. Which means that our hexagonal prism is also wrong. The parallel to the base of the hexagonal prism will be a hexagon. And then perpendicular will be a rectangle because it's a prism. We're going to cross that one out too. Next up, it says circle O is centered on the origin. So what does the origin mean? It's the center is at 0, 0. And has a diameter of 17 units. Now be careful. That means that the radius is half of that. And half of 17 units is 8.5. Determine if the point -3 to radical 10 is on the circle. Explain your reasoning. Well, I first want to write the equation of this, and you'll see why in a moment. If we write the equation of this, we get, x squared plus y squared equals 8.5 squared. Now we could simplify this. We could write it as x squared plus y squared equals, and let me pull up my Desmos calculator, where it comes in handy. 8.5 squared gives me 72.25. And now, in order to see if these fit, well, this is a coordinate, which means this is my x value and this is my y value. We could plug it into this equation that we have here, aka substitute it in. And then when we substitute it in, we can see if the two sides are equal. It's that simple. So what I'm going to substitute in for my x, instead of having an x here, we're going to put -3 squared plus, instead of having a y, now obviously this one's a little more complicated, but we just plug in 2 radical 10 and we square it, which is equal to 72.25, or else we hope it is. So now I can't do this in my head, right? Well, I could, but you might not be able to. So what can we do? Oh, that's right. We could open our Desmos scientific calculator. So we could just put it right in. So we get open parentheses, right? And then we go, where's my negative sign? Oh, we just put -3, close parenthesis, plus, open parenthesis, 2 radical 10. Click out of the radical, close parenthesis. And all we have to do, oh, I forgot something. We forgot our squares. So you have to go back, square that one, and we get our answer to be 49. Now, I don't know about y'all, but 49 is not equal to 72.25. So here we get 49 is not equal to 72.25. So what does that mean? The point is not on the circle. I'll put an exclamation point to really drive it home. So once again, what did we do here? We wrote our equation, we plugged the points in, and we said, hey, are these two sides equal? In this problem, they were not. Next up, back to cross sections. It says, what two-dimensional cross section do a cube and a square pyramid have in common? Well, the cube only has one cross section. And when we take the cross section of a cube, it is only going to be a square. So the next one, square pyramid, has a square base, which means that there is literally only one option available here, and it's going to be D. Triangle's wrong, octagon's wrong, hexagon's wrong, ellipse is wrong. The only one we need to know is that square pyramid. Or the square, sorry. All right, our next one says the equation x squared plus y squared minus 4x plus 2y equals b describes a circle. Now, just reading that equation, it might look off to some people, which is good, because that equation is not in the form that we want. I'm not even going to look at part A or part B yet. The first thing I want to do here is put that in a form that I like, right? So let's do that. And when I say I like, the form that we're comfortable with, our standard form. So this should really be rewritten first. So we're going to write x squared. And I want to get my x's together. So my other x is my negative 4x. So I'm going to put minus 4x. And we're going to leave a space here because we're going to have to do like we did in our other problem, complete the square. And then we're going to get plus y squared plus 2y, leave my space, equals b. And now we need to fill those spaces in. So once again, just like I said last time, we take the number next to our variable without an exponent. So I'm going to take negative 4. We're going to divide that by 2. So I'm going to do it over here. Negative 4 divided by 2 will give me negative 2. Then we square that, and that gives me 4. So I'm going to add 4. And we want to do it to both sides. This is, oh, let me make this look more like a B. Still looks like a 6. B. There you go. Kind of like a B. So we have B plus 4. And then I need to do the same thing for my Y. We have 2 divided by 2, which will equal 1. We square that, and that still equals 1. So we add 1. So plus 1. And now we just have to factor both sides, right? And remember, this number here is what's going to end up our factor. So I'm going to get x minus 2 squared plus y plus 1. Here's my minus 2. Here's my plus 1 squared equals, and then we could just kind of simplify this, and it'll be b plus 5. That's got to stay there. Now, I know this b plus 5 is confusing because we never had b in our problems before, but that's going to come into play a little later. So now let's look at our part A and our part B. Now that we got this cleaned up, we could recognize this left side, and our right side will get together later. So it says, determine the y coordinate of the center of the circle. Show all your work, which we did our work already. We just need to figure out my y coordinate, which is going to be here. The y coordinate is just going to be the opposite of this plus 1, which is going to be negative 1. And there's our answer. Nice and easy. This show all your work is already done. We did all that up here. Next up, says the radius of the circle is 9 units. What is the value of b in the equation? So what it's asking is, what could we plug in for b to have our radius be represented here? Now, in our original equation, we usually have r squared on that side, which means 9 squared, which is going to be 18. So now we can say that 18 is equal to b plus 5. And all we have to do in order to figure out what b is subtract 5 from both sides. And we get 13 equals b. And there is my answer. Cool. So I know this is a lot of work and it could be a little confusing. For this review, if you are confused or if you need me to explain any of this in further detail, please let me know either in the comment below or raise your hand and ask me. If you're one of my students, if you're one of Miss Harrison's students, ask her. And if you're someone else's student and you're confused about this problem, you could ask your teacher too. And our last problem, it says, which of these points is on circle, should we say the circle, is on circle with a center of 0, 0 that includes point -1, -3. So let's figure this out. And you might be saying, how can I figure this out? Well, the question is let's write our equation here. And how can we write our equation? Well, we don't know our radius, so let's find it. And how can we find it? Because if we think about this, our standard equation is x minus h squared plus y minus k squared equals r squared. We don't know r squared, but we know x, h, y, and k. Here's my x, here's my h, here's my k, here's my x, here's my y. Right? Because this is my center points, which is the h and the k. And then this is a point that we want to substitute in. So we could do this. We could say, hey, -1 squared, because it's a -0. -0 means nothing. Plus -3 squared equals r squared. Well, I know what all this is. This is going to be 1 plus 9 equals r squared. And then next up is going to be 10 equals r squared, which really just means r equals radical 10. So now we have to go back and think about what our equation is going to be. And our equation is just going to be x squared, because we're at the origin. Whenever you're at the origin, your left side of your circle equation is going to look like this: x squared plus y squared equals, and then we're going to write, what is my radius? My radius is square root of 10, but since we're squaring it, we're just going to get 10. Because this plugged into here cancels. So now what do we have to figure out? Well, we have to figure out which of these fits in. And if you plug these into a calculator, what's going to happen is this one's not going to work. This one will not work. This won't work, but this one will. So I could show you on my Desmos calculator when I bring it over. If we substitute this in, remember, it's just x squared plus y squared. We want to substitute it in there and see if it equals 10. My x is radical 10, so we could say radical 10 squared plus 0 squared. And what does that give me? Right here, it gives me 10. There you go. That's the answer. Now, obviously, I knew this off the top of my head. I'm a professional person at doing math, right? I'm your math teacher. But a lot of us will not know that, which means another way you could find this out is by plugging these in. Obviously, if you started at A, you would know right away that that one works, because then both sides equal 10, right? This would give us this right here. I'd show you the work for A. If you plugged it in, you get radical 10 squared plus 0 squared equals 10. Radical 10 squared is equal to 10 plus 0 equals 10. So then we get 10 equals 10, and we know that that's true. So that's how that would work, right? But if you didn't know that, you could plug all of them into a calculator and double check your work. Now, once again, I know some of these problems are complicated. I know some might be a little confusing. If you need any more help, ask me, ask Miss Harris, ask your teacher, or drop a comment down below on the video, and I will do my best to help you out. But thanks for watching. Good luck, and see y'all next time. Peace.